Okay, so again, notice that I skipped a problem, so I'm going to go to number 7, and this will actually be the last one I'm going to do. Again, I will post the answer key for the problems, all the problems from the task, including the ones that I didn't make videos about, so that if you want to use those as extra practice, you'll know what the answers and all of that was supposed to look like. So the reason why I'm going to do this one is because this one's not factored for you like all the other ones have been. So when I find the x-intercept, I'm going to have to factor that numerator to figure out what the two x-intercepts are. So I've got x squared minus 1 equals 0. That's a quadratic, so you're going to solve it by factoring x plus 1, x minus 1. And that's going to give you two x-intercepts. One of them is at 1, one of them is at -1, which means you have two coordinate points, -1, 0 and 1, 0. The y-intercept you're going to find by plugging 0 in for the x's. So the x's we're going to ignore here, and we're just going to look at -1 over -16, which is a positive number, 1/16. That is a coordinate point at 0, 1/16. So you're just barely above the x-axis. Vertical asymptotes, just like the x-intercepts, you're going to have to set the denominator equal to 0, and you're going to have to factor just like we did for the x-intercepts. That is going to be my x plus 4, x minus 4 pattern, which gives me two vertical asymptotes, one at 4, one at -4. Come down about proper versus improper fraction. We have same degree top and bottom because they're both x squareds, so that is an improper fraction. End behavior is going to be found by dividing the leading coefficients since the degrees are the same. That's one of the rules we talked about in class yesterday. The leading coefficients here are both 1s, so that means my end behavior on both sides is going to go towards the number 1. Because those are both numbers that are the same on both sides, we have a horizontal asymptote at 1. Using all of this is a lot of information to put on the graph, which is nice. It makes it easier to graph these when the more information that you get while you find all of your features. So my x-intercepts at -1 and +1. I have a y-intercept at 1/16, so just above the x-axis. Vertical asymptotes at -4 and +4. And I have an end behavior at +1, or a horizontal asymptote at +1. Notice in here how I have 3 dots already. So what we need to figure out is, as I hit this dot, these are going to obviously connect. So when I hit the 1, is it going to bounce and go up, or is it just going to pass through the x-axis and continue down forever? Same thing with the -1. Am I going to hit the -1 and bounce up, or am I going to hit the -1, pass through, and continue on? If you're unsure, guess what you can do? Plot a point. So on either side, how about we plot -2 and +2? And when we do that, those values, if I get a positive number, it's going to lead me to tell me that I'm going to bounce and go back up, bounce and go back up. Or if I do and plot a negative number, or it gives me a negative number, I should say, then it tells me I'm going to pass through the x-axis and then continue down forever. I know that I can't curl back up and hit the x-axis again because those are the only two x-intercepts that we found. So if I plot at -2, we get a value that is -1/4. So I know I'm below the x-axis, so this is going to continue down forever is what that tells me. On the other side, plot +2, and it gives me the exact same value of -1/4. That means that I'm going to be below the x-axis, and as I connect these, they're going to hit and then continue down forever. Now I need to figure out where the left side of the graph over here and the right side of the graph go. Am I above the horizontal asymptote, or am I below? Am I above or am I below? And I can easily figure that out by plotting a single point on both sides. So if I plot 1 point on the left side and I get a number bigger than 1, I know I have to be above. If I get a number smaller than 1, then it's got to be below. Same thing is true on this side. So I'm going to plot -5 and +5. When I plot -5, it gives me a value of 2.7. That means that I am above the horizontal asymptote. So that means that this entire piece of the graph is also going to be above the horizontal asymptote. On the right side over here, if I plot positive 5, I also get a value of 2.7. That means this piece is also way up here. So I'm going to have a piece that's above, again, the horizontal asymptote. Again, had this point come out negative, I would have known that entire portion of the graph was down here instead. If that point had been negative when I plotted it, then I would have known this entire piece of the graph would have been down here instead. So there's what my graph looks like. Now I'm going to piece together my domain by saying all real numbers, and I'm going to take out any of the vertical asymptotes, which are 4 and negative 4. If you want to do interval notation, you can. You need an interval smaller than negative 4. You need an interval between negative 4 and 4. And you need an interval from 4 and larger.